Okay, this is my first attempt at using the PowerPoint presentation with a Mimeo pad and some different things. So hopefully you guys can kind of follow. But the one thing I do want you to currently have with you in order to take these notes is your learning log, which is the papers that I just passed out to you. I'm going to slide it in front of the screen real fast. I know it's kind of dark, but this is what you have currently, okay? And that's what you're going to use to take your notes. And today we're going to be talking about the properties of algebra. So if I go to the very first screen, it says do now. So these are 3 problems that I want you guys to do. And you'll notice at the bottom, let me see if I can switch to a laser pointer here and then I can kind of show you. Okay, so then down here at the bottom, this is where you're going to do those problems. So number 1 on your paper should be done in this first box. What program do I, Miss Crimes, use for you to receive your notes? And that would be the program that you logged into today and created an account. Then the second problem, what is the y coordinate for this point? In other words, which one tells you which direction to go up and down? And that one you're going to answer here. And then number 3, describe the location of the ordered pair -5, 4. And that means tell me how to get there. Do I go right, left, up, down? Where do I go to get to this point? And you're going to put it in this box. Okay? Please try to write in complete sentences because that's good practice for you. So then once you complete those 3 points, we're going to move on. So again, if you're looking at your notes, we've now moved on. And we are looking at this portion right here that says define the word commute or commuter in your own words. And I basically kind of gave you a hint by this picture on what a commuter is, or the word commute. Okay, and it's a little dude inside of his car with his coffee and his briefcase, and it says, I wonder what the traffic will be like today. No wrecks, please. So in your own words, in a complete sentence, write in this box on your paper what you think the word commute or commuter means. And then the next couple of slides are the same thing. So now if you, I want you to define distribute or distributor in your own words. And again, I've given you a couple examples. Donald Duck, the mail carrier, he's distributing mail. And a newspaper guy, probably from New York, who is distributing newspapers. So go ahead and in this box where it says define distribute or distributor in your own words, go ahead and write in complete sentences what you think a distributor is. And guys, remember, if you need to pause the video to do this, please pause the video. Alright? And then the last one goes in this last box. It says define your associates or who you associate with in your own words. So we're defining your associates or who you associate with. So what do you think associate means? And then again, I have a picture of kind of a group up here. Okay? Alright, so now that you've kind of defined those in your own words, we're going to apply those mathematically. Okay? So we're going to talk about the commutative property, and I've just kind of thrown 2 pictures up here. The commutative property says 2 plus 3 would be the same as 3 plus 2. That changing the order did not change the result. And then there's kind of another picture which gives you the same problem but in a different way, but using that word commutative again, where we talked about a commuter. And now that you have that on your own paper, we can kind of talk about that. Commute is somebody who drives back and forth to work. And so that's what these cars are. This one is going this way, this one is going this way. So if you started at 2 and you went to 3, so in other words, you started at home and you went to work, then on your way home you would start at work and go home. And that's kind of how the commutative property works. If I add 2 plus 3, I get 5, but if I add 3 plus 2, I still get 5. So let's look at the next slide because it kind of gives you the stuff to fill out. So here's these 3 boxes. Define the commutative property. Well, here's the definition. The commutative property states that addition and multiplication can be done in any order with the same result. And then down here it says recognize the property. So how would you recognize the commutative property? Well, that's this part down here. When you're looking at an equation, the numbers should be exactly the same but in a different order. So let's look at that for a second. So this first equation that I gave you as an example, this first number right here, this is 3x, right? So this was my first number. And then my second number, let me change colors here. I think I know how to do that. Is here. Maybe I changed colors. And then our third number is here. Now, if I use the same colors on this side, so here's this one, and I should have done this at the same time, but like I said, bear with me, this is the first time I've tried to use this type of a program to do this. And then our green. So notice on this side, we did red, which was 3x, green, which was negative 5y, and blue, which was 8z. On this side, we have the same numbers. There's the 8z, there's the positive 3x, and there's the negative 5y. Okay, but the difference is that they've moved. So the 3x was first, but now the 3x is in the middle. And then the 5y was in the middle, negative 5y, but now it's on the end. And then here's the 8z, the positive 8z, now moved to the front. So each term is the same, but it's in a different location. And that's what we mean by, when looking at the equation, the numbers are in exactly the same, or the numbers are exactly the same, but they're in a different order. Okay? So same thing here, we have 7x, and then we have the 4y and the negative 11c. Here we have 7x, which is in the same spot, right? They're both first, but then we have the negative 11c and the 4y. So these two switched places. And it's still commutative because it's the same exact pieces, the same numbers are even inside the parentheses, they just switched locations. Okay? And then this is another example, but instead of putting A, B, we grouped the A's together in the front and the B's together at the end. And this is a pretty common practice. Okay? So you should now have this whole column filled out. So define commutative property, which was this part up here. Then recognize the commutative property, that's this part down here. There we go. And then here are your 3 examples, and those can go down here in this box. Okay. So here's distributive property. So the distributive property kind of shows the Angry Birds. When we've got an Angry Bird outside of parentheses, and then all of a sudden we have the Angry Bird with this guy, and then this Angry Bird with this guy. So we've paired them up. Same thing down here. We've distributed, or we've given the 5, or multiplied the 5 times everything inside the parentheses. So 5 times the m, and 5 times the 12. So then they performed the operation. 5 times m was 5m, and 5 times 12 was 60, so this was our result. Okay, and then this is again just another example. So what goes in your boxes? Well, here's the information. So here's our definition. The distributive property states that the number on the outside of the parentheses is multiplied by each term on the inside of the parentheses. So automatically we know we have to have a set of parentheses on one side, but because we multiply it through, we won't have parentheses on the other side. So your big recognition is that it removes the parentheses, and that's what I put down here. The easiest way to recognize the distributive property is that there's only parentheses on one side of the equation, or the distributive property removes the parentheses from one side. So here's some examples. We have 3 with parentheses n plus 5. If we distribute, 3 times n gives you 3n, and then 3 times 5 gives you the 15. And some of your teachers probably, let me change to a pen, did this, and they did little arrows like this for you so you could see, okay? So then this is the same thing. 7 times the 4y gave me this 28y, and then 7 times the negative c gave me negative 7c. So we have parentheses on one side, but not on the other, and that's how we recognize the distributive property, okay? This third one is the same thing, but our parentheses are on the right-hand side. So if I do the 4 times the 2c, that's where I got this 8c. And then the 4 times the 3 gave me this 12. And then the 6b is still just kind of sitting out here. But again, we had parentheses on one side and not the other. So again, this middle column should now be filled out. Your definition of distributive is up here. How you recognize it is down here, or you could put in a complete sentence that it removes the parentheses. Okay, and then the examples are right here in the middle. So again, now this column and this column should both be filled out on your notes. All right, let's keep moving. Here's the associative property. Associate means who do you hang out with, okay? Who do you associate with? So for me here at North Crowley, it might be that I'm going to associate with the soccer girls, but then I'm also a math department. So I may go and hang out with the math department. So this shows, here's me, okay? Call me the yellow dude. And this is me hanging out with the soccer people, okay? So my first grouping, which is the parentheses, is me hanging out with the math people or the soccer people, it doesn't matter. And then the other people are hanging out here. So let's do math, me, soccer. So here's math and me, but then on the other side, here's me and the soccer people. Okay, so it's just who I'm associating with or who I'm grouped with that changed. So if you look at it mathematically, they've given you some examples. A plus B plus C is the same as A plus and then parentheses B plus C. So your associate property is that the numbers can be grouped differently, but you still get the same answer. So let's go ahead and fill out our columns. Okay, so here's what it looks like. Our associative property states that when 3 or more numbers are added or multiplied, it does not matter which terms are added or multiplied first. So in this first one, here's our grouping, and we're going to do the 5x plus 3y first, and then we're going to do 4 plus that. But on the right side, we move the parentheses around the first two terms. And so now we have 4n plus 5x first, and then we're going to add 3y at the end. So again, the easiest way to recognize the associative property is to look at the numbers that are inside the parentheses and see if they are different pairs. So here was 5x and 3y, here was 4n and 5x. Okay. Here is 8 times 3x first, but over here I have 2y and 4c first. So it's just that we've changed the parentheses. It was around the first two terms, and now it's around the second two terms. And then the same thing on this one. So you've got your definition up here at the top, so you'd copy that. You have how to recognize the associative property down here at the bottom, and then you have your 3 examples right here in the middle. Okay? All right, moving on. And again, remember, you can pause the video at any time. So let's practice. So here's our first problem. It says, which property is this? Is it commutative, associative, or distributive? And it says, remember to look for your telltale signs. So, are the numbers in a different order? Are the numbers in the parentheses different? Or is there parentheses only on one side of the equation? Well, this one's pretty easy because the associative and the distributive both have to have parentheses. Does this have any parentheses? No. So we know that this is the commutative property, which means that the numbers should be in a different order. Well, if we split the problem down the middle, oops, I just picked a highlighter, hold on. If I split this problem down the middle, on this side I have 7x first and then plus 8y second. On this side they've been flipped. 8y is first and 7x is second. So we would say that this is the commutative property. and that these just flipped places on that side. Okay? And then what would be our justification? It would be commutative. So we would say the numbers, and I can't write in those boxes, are the same, but in a different order. Good. So let's look at another example. So we do have parentheses this time. That doesn't mean that it's not commutative. So we could check to see that the order, but we might as well check this first. Are the numbers different in the parentheses? Wow, that's not a very good sentence. Numbers different in parentheses are different. This shouldn't be there. Sorry. The numbers in the parentheses are different. Well, if I look over here, I have parentheses. But if I look over here, I don't have parentheses. And that, we already said, was a telltale sign of the distributive property. The parentheses are only on one side. So let's check and see if we multiplied. R times 3 does give me 3R. And R times 4T does give me 4TR. There's another edit. Okay. Apparently it's not here, but it is up here conveniently. So we would say that this is the distributive property. So you would circle that here. And then your reason would be that there's parentheses only on one side of the equation. Okay. All right, last example before you do them on your own. So on this one, we want to see if they're in a different order. Well, it's 6x and 9 and 7y. Well, if I look over here, I have 6x, 9, and 7y. So they're in the same order, so it can't be commutative. So let's check the parentheses. Are the numbers in the parentheses different? So if I look, on this side, I have 6x and 9 in the parentheses. On this side, I have 9 and 7y in the parentheses. So yes, the numbers that are in the parentheses are different. Therefore, this would be the associative property, and my justification would be that the numbers in the parentheses are different on both sides of the equation. Good. So I've got 4 of them that I want you guys to try to do on your own. Okay. So these 4 are on your paper, and you're going to do the same thing. You're going to circle whether they're commutative, associative, or distributive, and then you're going to give me a justification or a reason why you think that they are what you say they are. Okay? And then the last thing I want you to do is I want you to pick one of the 3 properties and create your own example. And that's going to be right here. And then justify for me why it is the property that you picked. Remember, I am still in the room, so if you have any questions or having any trouble, please let me know. Have a good day.